Welcome students. In previous class we have discussed about thermal expansion, expansion of solid, liquid and gas and many more things. So now we are discussing new chapter, transfer of heat. Okay. So heat transfer, we know there is a three mode of heat transfer of heat. One is called conduction, convection and radiation. Okay. Conduction means the during you can take an example that during the cooking the heat energy providing the lower surface of our um, container or jar, and the upper surface is heating or some upper surface, the food is cooked by the heat energy, and this heat energy transferring from lower surface to upper surface of a container by the process of conduction. Convection is the process through which the medium can move and transfer the heat. Okay, and in the radiation the process there is no medium is required. Okay, this is the process of radiation, that the heat is here, heat is transferring from this side to this side. Okay, this is called, this process is known as conduction. Okay, conduction. And material is not transferring. Okay, material is stable at its own position. Okay, this is the called convection. Convection, the water or liquid of lower surface heating and moving upside, and upside cold water or cold liquid going downward and again heating and it moving upside. That means the material is moving and uh, okay, carrying the heat energy. And the sun energy coming out from sun to the earth is the process, in the process of radiation. No medium is there in between them. Okay, and also the heat in winter region, we take heat energy from any burning wood or anything, and this radiated heat is coming to our body. Okay, conduction. So now we will discuss about the process conduction, the process of transmission of heat energy in which the heat is transferred from one particle to other particle without dislocation of particle. This is important, without dislocation of particle. Okay, and from their equilibrium position is called conduction. Okay, now for conduction we have to understand steady state and temperature gradient. Okay, steady state and temperature gradient. Suppose we are hitting this rod and the left side of this rod is hitting. Okay, and suppose two thermometer A, B and C, so three thermometer are taken here, and now reading of thermometer A is theta A, B is theta B and C is theta C. Okay, at first, when suppose at time, if I plot time theta A, theta B and theta C. Okay, suppose at time t equals to 0. Okay, time t equals to 0, and we are start the heating the rod. Okay, then theta A equals to, suppose this is 20 degree C and theta B also 20 degree C, near about same. Just starting at the starting time. Okay, after 5 minutes, suppose after when time is 5 minutes over, now theta A may be reached to 40 degree C and theta B may be in 25 degree C and theta C near about suppose 22 degrees. Okay, after 10 minutes you can get theta on suppose 60 degrees C, this will be 35 degrees C and this is something 30 degrees. Okay, that means with increasing time the heat temperature gradually increasing, but after some time, suppose after 20 minutes, suppose the theta A now 100 degree centigrade and theta be now suppose 80 degree centigrade, and theta c now suppose 60 degree centigrade. Okay. And if I after 30 minutes you can get same 100 degree centigrade, 80 degree centigrade and 60 degree centigrade. Okay. After 1 hour again you can see this is 100 degree centigrade, 80 degree centigrade and 60 degree centigrade. Okay. Because initially the rod, some amount of rod taking energy to increase its internal energy, means its temperature, and rest of the part is transferring. Okay. So some part is taking to increase its energy and rest of the part transferring. And after some time when the after some time the material, whatever amount of required energy to reach temperature, it's absorbed, and the rate of transfer of energy gradually increasing so that its temperature now constant. Okay. So these initial states are called unsteady state. That state we have no equation and calculation. Okay. For steady state, this region, in this region you can see with when time passed, then temperature constant, but temperature is not constant everywhere, but temperature at particular point is constant. Okay. This state is called steady state. Okay. At steady state, temperature near the burner is high, around 100 degree, and then if we go far from the burner, then you get the gradually temperature decreasing. Okay, like this. So we have all the calculation in steady state condition. Okay. So at steady state, the temperature of each point is same, but not sorry, each point is independent on time but not same. Okay, this is called steady state. And another term is temperature gradient. Temperature gradient, rate of decrease of temperature. You can see if you go far from burner, your temperature gradually decreasing, and then rate of decreasing of temperature, sorry, decreasing of temperature per unit length is called temperature gradient. Okay. So del theta by del x, suppose there is a high temperature theta 1 and this side theta 2, and heat is flowing from this portion. Okay. Then the change in temperature per unit length is called temperature gradient. Okay. D theta by dx. Okay. In large scale you can say theta 1 minus theta 2 by x. Okay. Suppose this is the x. Okay. And this is theta 1 and theta 2, then temperature gradient you can say theta 1 minus theta 2 by x, and for small scale reading, small scale value, we can say d theta by dx. Okay. Here is a question: under steady state the temperature of body increase with time, decrease with time, does not change with time, and its small at point of the body does not change with time and can be different in different point of the body. Option will be 4, does not change with time and can be different at different point of the body. You can see the temperature of the different point of the body is different, 100, 80, 60. Okay. Now we have to come to a mathematical term. Okay. Rate of flow of heat. Rate of flow in now flow heat, amount of heat flowing per unit time. Okay. So suppose this is a conductor. Okay, this is a conductor. Heat is flowing. There is a warm body is taken one side of a conductor, and a cold body is taken to the another side of conductor. Okay, so heat is coming from warm body to colder body. Okay, flowing through this that way. So amount of heat flowing Q in time t. Suppose you have to calculate, then Q should be proportional to a cross sectional. If you increase the cross sectional area, amount of heat flow will be increased. So just compare with the water flow through the pipe. If we increase the cross section area of the pipe, then the water flow rate will be increased. Okay. and Q proportional 1 by L. Means if you increase the length, rate of flow will decrease because there is a resistance. Okay. In case of water flow also, if you increase the length of the pipe, then the rate of water flow means speed of the water will decrease. And Q proportional to T1 minus T2, temperature difference. Okay. Suppose temperature you can say T1 or theta, you can take theta 1 and theta 2 also. Okay. And Q proportional to time. With increasing time, amount of heat flow will increase. Okay. Then if you compare all the proportional, okay, and uh, join this, then you get Q proportional to A theta 1 minus theta 2 into T by L. Okay. And then there will be a proportional constant. Okay. And this proportional constant is K. K is called thermal conductivity. Okay. K is called, and rate of heat flow Q by T, okay, is equal to Ka T1 minus T2 by L, or you can say Ka theta 1 minus theta 2 by L. Okay. And the rate of heat flow is called heat current. You know, in electricity, current is rate of flow of charge. Okay. And here for heat conduction, here heat current is rate of flow of heat energy. And you can say water current is rate of flow of water. Okay. So Ka T1 minus T2 by L. K is called conductivity. So what is the definition of conductivity? Okay. So definition of conductivity will be when A equals to 1, okay, and T1 minus T2 equals to 1 and L equals to 1, means the length of the rod should be, suppose you take a cubical body having unit length, side 1 meter, okay, then cross section area will be 1 meter square, and length will be, suppose this is theta 1 and theta 2, then this length will be also 1 meter. Okay. Then if the rate of heat flow from between two opposite sides of a cubical body having unit dimension is 1 meter or unit dimension, then this rate of heat flow will be K. Okay. You can say equals to 1 T1 minus T2, and also T1 minus T2 will be 1 degree centigrade or 1 unit, and L equal to 1, then K equals to Q by T. Q by T means rate of heat flow. Okay. This is the definition of thermal conductivity. So the definition of thermal conductivity will be rate of heat flow per unit cross sectional area per unit time. Oh, sorry, rate of heat flow I have told per unit length. Okay, this is called coefficient of thermal conductivity. So if K is high, then rate of heat flow will be high, and if K is low, rate of heat flow will be low. You can see here, I have given an example that this is a pressure cooker, and this pressure cooker, this portion is high heat conductivity, this is high conducting, highly conducting. So if you put on your burner, then heat energy transfer from lower surface to upper surface of conductor. But the handle of this uh, pressure cooker, the conductivity of this handle is very low, so that it cannot heat up, means heat energy can not transfer very easily or conduct easily from the high temperature to low temperature. That's why it is becomes cool. Okay. So we can uh, take it by the handle. Okay. And in case of frying pan, we know wooden handle, wood has low conductivity. Okay. And heat current, I have told heat current means del Q by dt, K T1 minus T2 by L. Okay, or you can say minus K del T by L. Okay. So your unit will be H joule per second del Q by del T. Thermal resistance. So you know, you have told according to Ohm's law, if a conductor is connected uh, with the battery, suppose this is a conductor has resistance R, and if you connect this battery of V volt, and if I current is flowing, V equals to IR according to Ohm's law, and I equals to V by R. This is current. V means potential difference. You can say suppose this side potential V1, this side potential V2, then V1 minus V2 by R. Okay, V1 minus R. Again, and you know the R is the resistance, and R is you have studied the rho into L by A. Oh, sorry, rho into L by M. Here L is the length, A is the cross section area, and rho is the resistivity. Okay. And here thermal conductor, you can see for a thermal conductor, and if theta 1 and theta 2 be the temperature, then thermal current H equals to K theta 1 A theta 1 minus theta 2 by D, or L, length L. Okay. So, and then you can say, suppose V1 minus V2 by R, here you can say theta 1 minus theta 2 by RH. RH is called heat resistance. Okay, heat resistance. And here current for current electricity, current is flowing due to potential difference, and in thermal heat transfer, in case of conduction, the heat is conducting due to temperature difference. Okay. So here you can compare this RH equals to 1 by K A by K L. You can see, oh sorry, L by K. 1 minute. L by K into A. Okay. Suppose you can compare the rho L by A. Here you can say 1 by K into L by A, and K is called conductivity. Also it can be called electric conductivity for electricity. Okay. And here you can see, so RH will be L by K. This is called, suppose 1 by K into L by A. R equals to here rho L by A, and R is equals to 1 by K into L by A. This is called heat resistance. Okay. And in case of series combination and parallel combination of resistance, you have studied in electrical resistance, and also the series and parallel combination of heat resistance, electrical resistance. And you can see here that the thermal resistance is mm, similar to the electricity resistance. Okay. And you can here compare here analogy that electric conduction and thermal conduction. I heat current is dq by dt, and H equal to dq by dt. This dq is rate of flow of charge, and this dq by dt is the rate of flow of heat. Okay. According to Ohm's law, I equals to V1 minus V2 by R. Here H equals to theta 1 minus theta 2 by R. Okay. And R equals to rho L by A. Here R is 1 by K by, or L by sigma. Sigma is the conductivity, you can say. Okay. And same things like that. And in series and parallel combination, you will get same result, that in series combination R equals to R1 plus R2 plus R3. In here you can see RH equals to RH1 plus RH2 plus RH3, and in parallel combination 1 by RH equals to 1 by RH1 plus 1 by RH2 plus 1 by RH3, RH3, like that. Okay. And conductivity is the completely material property. All the copper has same conductivity, all iron have same conductivity. Okay, like this. Here a question: you can see, among the following cylindrical rod, in which rod rate of conductor of heating will be maximum? So rate of conduction means heat current will be maximum if the temperature difference between end is same. Temperature difference is same. Alright. Okay. So length 2 meter, radius 1 meter. Suppose, so H, you know, H equals to 1 by K into L by A. Sorry, uh, 1 minute. K A theta 1 minus theta 2 by L. Okay. Means if A by L, you can see all the material made of same material, all the rod. Okay. That's why K is same for all rod, and theta 1 and theta 2 same here given. Okay. Then A by L is varying. So H proportional to A by L, or you have to find the A by L, which have A by L maximum means H maximum, A by L minimum means H minimum. Okay, A means here pi r square by L. Here in case of A, you can see here A length is 2 meter and radius 1 centimeter. So pi into 1 square by L2 here. That means pi by 2. Not necessary to change the dimension. Here length is 2 meter and radius 1 semi. So you can change here the 2 meter, you can write 200. Okay. And in case of B, 4 meter and 2 centimeter. Pi into 2 centimeter into 4 by pi r square. 4 by 4 meter or 4000. Then you can see pi by 100. Okay. Here pi by 100. In case of C, here pi into 2 square means 4 by 200. That means 2 pi by 100. Okay. And here in case of D, pi into 4 square, when 4 into 4 by 2. That means 8 pi. So maximum will be D. Okay, 8 pi. Oh, sorry, here 200. No, 200. Sorry, there will be pi by 4 pi by 100. Okay, this is maximum also here now. 4 pi by 100. Okay. Next, combination of conductor. I have told series combination and parallel combination. Suppose two conductor connected in series. Okay, so we have to find equivalent conductivity, or first you have to find equivalent resistance. Okay, then you can find equivalent conductivity of this. They have conductivity K1 and K2. Cross section area is same for two, and temperatures are theta 1, theta and theta 2. Lengths are L1 and L2. Okay, so you have to find K equivalent. Okay, and you know, if as they are connected in series, then equivalent resistance will be R1 plus R2. Okay, suppose just like resistor. Okay, then R equivalent will be, you know, the R equals to rho L by A, you know, some L by A, rho means 1 by K. Okay, that means 1 by K equivalent into length will be L1 plus L2 by area A. Okay, R equivalent. R1 means rho L by A, means L1 by K1A plus L2 by K2A. You can calculate K equivalent, that K equivalent will be L1 plus L2 by L1 by K1 plus L2 by K2. Okay, this is the K equivalent. Yeah. And another term is temperature at the interface, a middle interface. At the interface means this. You have to find the temperature at the interface. Okay. So to find the temperature of the interface, so rate of heat flow means heat current is flowing through this, it's same as heat flowing through this. Just like series resistance, the whatever amount of current flowing through R1, same amount of current will flow through R2. Okay, that means the rate of flow means V by R1, theta 1 minus theta by R. We know the current is V1 minus V2 by R. Okay, just like that here, V1 minus V2 is converted into theta 1 minus theta 2. Theta 1 minus theta by R1 equals to theta minus theta 2 by R2. And you can calculate theta. Okay, so theta 1 by R1 minus theta by R1 equals to theta by R2 minus theta 2 by R2. Then theta into 1 by R1 plus 1 by r2 equals to, there will be theta 1 by r1 plus theta 2 by r2. Then theta will be r2 by 1 by r1 plus 1 by r2. Okay. That way you can calculate the temperature at the interface. Okay. Parallel combination, equivalent distance, if r be the equivalent distance, then 1 by r equal to 1 by r1 plus 1 by r2. So here you can see the K1 and K2 are the conductivity, then you can to calculate equivalent thermal conductivity. 1 by r means rho L by A, L by A into K. Okay, so there will be K A by L. Okay, equivalent, K equivalent, A will be 2A here. Okay, A will be K into 2A by L equals to, here will be K1 into A by L plus K2 into A by L. Okay, you can calculate K equivalent will be K1 plus K2 by 2. Okay, and in series heat current you can calculate theta 1 by theta 2 by R1 plus R2, theta 1 is L1 by K1A plus L2 by K2A, like this. Okay, that these questions are very easy, you can calculate. I have explained, I will explain this problem. Here the question is, three rod made of same material have the same cross section has been joined as shown in figure. Three rod having same length and same cross section area joined shown in below. Okay. Each rod of same length, the left and the right end are kept at 0 degrees and 90 degrees respectively. The temperature at the junction of the rod. You have to find the temperature at the junction. Okay. Here given the material conductivity ALK, all. So you can see the, if you don't understand that current heat along which direction heat will flow, no need to understand that which direction heat will flow. Just take that the temperature at junction is theta, say. Okay, and you can choose that the all the current is going out from junction. Okay, from junction all the current going out. Okay, so and whatever current, how many current will uh, go out from junction, total current going out from the junction will be 0, because some amount of current is coming and some amount of current going. Okay. So you can see here, then you have to calculate that all the current is going outward from theta. That means the K, sorry, all the K are here, Ka into theta minus 0 by L plus K into theta minus 90 by L plus Ka into theta minus 90 by L equals to 0. Then you can calculate theta plus 90 minus, theta minus 90, theta minus 90 plus theta minus 90 equals to 0. That means 3 theta will be 180 and theta will be 60 degree. Okay. Answer will be 60. So next questions you can try at your home. Okay. Next day we will discuss about more on this. Okay. Thank you.